Hello everyone, welcome to today's session. Today we are going to create our first React component with TypeScript. So before we dive into creating the component, we need to have a basic understanding of interface and types. Why do we need to understand interface and types? In TypeScript, we have two options for defining types of objects or data. It's basically through interfaces or types. So let's look at some code examples and then we'll come back to it. Let's start with types. So as you can see, here I've created a user type. This user type has a property name and a property age. So whenever you're defining a new user, you can define const new user of user type, and TypeScript will tell you what all properties would be available. So age, which is of type number as we can see, and name, which is of type string. So if I go down, you can see name of type string. So I can press and I can define them appropriately. Now another type can be defined, for example, employee type I've created, which has the properties email and occupation. Both are of type string, and occupation is an optional property. So an optional property is represented by question mark. So whenever an optional property is given, you do not need to have a value for that property or need to define it when you're creating an object of the particular type. Types allow you to have intersections in them. So intersection type, for example, I created a new intersection type employee, which is an intersection between the user type and an employee type. So it will have all the properties of user type as well as all the properties of employee type. So now in the employee object, you can add name, age, email, and occupation. So even though occupation is not necessary, you can go ahead and add that. If I add a control space, it'll tell me occupation by default is undefined, but if you're defining it, it has to be of type string. So I can define intern. If you remove any of the mandatory properties, you see an error comes up. The name is not assignable to type employee because property email is missing in your particular type. So we need to add email to make it compatible with this because email is a non-optional type for employee. So let's go ahead and add that. Now, next thing which types allow us to do is union. I have defined a type animal, which could either be a dog, cat, or a bird. Here, I'm defining a pet, which should be of type animal. And you see, I have the option to add it as a dog, cat, or bird, but nothing else. If I try to add a lizard, it will throw me an error. It is not assignable to type animal because it does not exist in the union types that we have created. And if you want to use that, you need to go ahead and add that. And now it will not throw the error that it's not a valid type. And this is what union type is. And it can be any value. So you can have 1, 2, 3, 4 as well. It does not have to be necessarily string. It could be either these and 1, 2, 3, 4. So union types can be created out of multiple values. Now types are specifically crucial when you're dealing with tuple. Tuple is an array of a fixed length and of fixed type. So here I've created a new tuple which would have 3 elements, only 3 elements, and all 3 have to be of type number, which I'm calling as RGB. So whenever I'm defining a color, I can have RGB and it would be of type number. If I try to add another number, it will throw an error. This is not assignable to RGB because you can only have 3 numbers. And similarly, if I add a string, now the error would be updated to show number and string is not assignable to type RGB. So tuple definition is very crucial whenever you're dealing with these types of data. String or number tuple is also available. So you can see if in your case, the first element of an array has to be a string and the second one has to be a number, you can define appropriate tuple type and use it in your code. How do we define? You define the variable and then colon the type of the variable that you want, and it will take hold. React also uses this. Whenever you're using useState, it will give you the value of the object as the first element and a function to set the values. So that's also one of the use cases here. Now, primitive types with type. People who might not know what primitives are, primitive types are most basic types in JavaScript. You have 7 primitive types, which are string, number, boolean, null, undefined, big int, and symbol. Big int and symbol are some of the things which you might not have seen regularly in your code, but remaining all types you might be using on a daily basis if you're working with JavaScript or React. string, number, boolean, null, and undefined. Okay. So whenever you're dealing with primitives, it's good to use types. So for example, I want to create a type ID which can either have a string or number as its value. And that's where we can define a type using primitives that, hey, type ID will be either a string or a number. So I can assign this to test, which is a string, assign this to 1, 2, 3, 4, which is a number. Perfectly fine. But if I move this to an array, it will throw an error. An array of number is not assignable to type ID. Now conditional types. So this angled bracket that you see is a generic type declaration. You might have seen it in your code. Don't worry, it looks daunting, but it's not all that difficult to understand. In here, what I'm saying, I do not know what the type of my object would be. Let's call it of type T. And we'll see if T extends string, the type becomes yes, else the type becomes no. This is all that conditional type is doing. So here, as you can see in result 1, I'm using this conditional type and passing string. So string extends strings, which is true. The result 1 would be of type yes. Result 2, it's passing a string, a value of a string. So value is extending string, which is true. You'll see the value is yes here as well. For result 3, I'm passing a number. So number does not extend string. It will return no. So result 3 becomes no. This conditional type becomes really useful when you have defined multiple complex types in your project and you want to check whether the object that you're receiving is of a particular type. So you can define methods like check type, pass a generic type, and then you can have multiple switch statements if conditions and all to see, okay, if this particular type is returning this, then yes, it is of this type, else no. So this is the implementation. Here also, I'm taking a generic T and the value which will be passed will be of the same generic type. So if I'm calling check type with string, it would be of type string. If I'm calling with a number, it would be of type number. And the return value would also be of type string. So we are using this conditional type that we created and calling it. Let's understand it better with an example. So I'm calling check types with hello, which is a value of type string. So check types automatically takes, okay, this is of type string, value is also of type string, and I have to return whether this is string or not, and this will give me this type. So it will check whether t extends string. So now here we are checking if type of value, which will give us string in case of hello. So we need to return yes, else we would have returned no. And this is of type yes or no as we defined in our conditional type. You can see result 1 is yes. And here we are passing a number. So result 2 is no. If it's confusing, please don't worry about it. You'll get better at understanding generics as we start progressing through our TypeScript application and courses and start implementing components in greater detail. Types can also be used to define function signatures. Here, I'm defining a new function signature. I can have a type of greet function which would take a name as an input, which would be of type string, and the output has to be of type string as well. Here I've created a function. I'm telling that it has to be of type greet function. So name, it implicitly assumes, okay, as per the greet function definition, that a name parameter is of type string. So it implicitly infers name is of type string. And here I'm returning hello name, which is also matching with the return type of string. If I remove this return statement, now we are no longer returning a string. So it will throw an error. Type name void is not assignable to type greet function. The void is not assignable to type string. So this way the tooling comes to your help. You can quickly identify, okay, I forgot to return something. Let me add that. And this will fix your issue. Now, with the understanding of types, let's try to understand interfaces in a similar manner. So, interfaces, why and how. Here we see types are mostly dealing with the data, what sort of data we are defining, the structure of the data, what it can have versus what it can't have, what type of values the data will have. Interfaces define the structure of an object. Think in terms of object, we want to define a person. So we create an object. Okay, whenever I'm dealing with a person, the person will definitely have a name and an age. So we define the structure of an object. Now, new user is created. We can tell, okay, it's of type person. And implicitly TypeScript will tell you name is already there. You need to add age as well. So you can add any age that you want. And it's valid as long as it matches the type declaration. The optional properties work here as well. Let's go ahead and add that. But before that, let's understand extension. What is extension? Interface allows you to extend one of the existing interfaces and add some new properties to it. For example, I have created an interface employee, which is extending person. So it will have all the keys or properties that a person has, and you can add additional properties on top of it. So I can tell, okay, name and age were already there. Let's add an employee ID and an optional email. Optional again, you start with a question mark and then the type of the property. So email is an optional property. Now you can create a new employee. Const employee would be of type employee. Okay, let's go ahead and add properties. On pressing control space, it will tell you every single property that is available as a part of its schema, the employee schema. Age, we can add anything. It has to be a number. Employee ID is of type string. Let's add that. EMP123. Now, you see, if you miss out any of the keys which are mandatory, it will throw an error. Name is missing. Let's add name. Now, all the mandatory keys are available. Name, age, and as per employee, employee ID. All three are present, so no more errors. But still, if you go ahead and press control space, an email property is also present, which is undefined by default. But if you are defining it, it needs to be of type string. So you cannot have a number. It will throw error. Number is not assignable to string. And once it becomes string, the error goes away. So this is how you can extend existing interfaces and add values to it. One more call out here. Interfaces support declaration merging. So for example, you can define an interface again and again and keep on adding new properties to it. Person, suppose it's coming from a third party library and you want to add a new property to person, which would be address. So you can define the same interface once again. Interface person should have an address of type string. Now, if you see everywhere where I was using person, it should have a name and age, and TypeScript internally added address as well to all the person definitions that were there. So if address is missing, it will throw that it's missing. If you want to make it optional, the error would go away. But now address would also be available on both the person type as well as employee, because employee is extending person and will have all the keys. So you see, address is available on employee as well. So this was on declaration merging, and this is supported through interfaces. And this way, they are much cleaner to understand and implement. Definitely, you can use types as well in combination with interface to make the overall value or type much more robust. Let's look at an example for this. Here I've created a union type, which is status. It can have three values. It could be active, inactive, or pending. Now, I've created a generic interface, which accepts a generic type T and casts it to data, which is an object here in the APIResponse type. It could be string, it could be number, it could be a very complex object, anything that you want. But the status would have to be of type status and message would have to be of type string. Here, I can use this API response that I've created, create two completely different data responses, one for a user and one for a product. As you can see, when dealing with user, what I've done for the generic type T, I'm passing the object which has an ID number and a name string. And you can see it automatically casts in data to that format. So if I remove this, and if you have to define, if you're working on a project where you got a type, you just need to press control space and it will tell you, hey, for this data, now you need to provide an ID which would be of type number. And you also need to provide a name which would be of type string. You see, there is an optional property available message as well, but it's not mandatory to put it. So it won't throw any error. Now, same API response type could be used to create a completely different response that you're expecting for product. Here, the status is inactive. What are the allowed values? Control space will tell you, or the auto completion for the ID that you're using will tell you. It can only have three values, which are active, inactive, and pending. We can have it as inactive for now. Now, the data again, if I remove anything, it will tell me, hey, price is needed and title is needed. You see? So that way we can create interfaces that can take generic types and mold themselves to accommodate for different various types that we need in our application. So this was a brief overview of interfaces and types. And this is enough knowledge to get started with component and is good enough to take you till a moderately complex React application. If you have a good understanding of everything that was there, you would be able to develop a moderately complex application with the basics that we covered here. Now let's go back to summary and understand When do we need interfaces versus types, and what are they? So now with the last example, we can summarize interfaces and types. Interfaces are designed primarily to describe the shape of objects. Interfaces support extension. As we saw, the employee extends person, making it useful when you want to add properties to existing structures. And interfaces are also ideal for defining object types, specifically when you want to extend them over time. As we saw, person was already there. We defined a new person, and declaration merging took care of merging both of them for us. So you can extend them over time. Now, coming to types, types are more flexible than interface, and they can describe unions, intersections, tuples, and primitive types. We all saw those examples. So, types cannot be extended like interface, but we can combine them using intersections. Types are better suited for complex type definitions. For example, whenever we are dealing with primitives, as we saw that ID can only be a number or a string, and then unions and intersections. As we saw in our API example, where we were dealing with the status union type, which could be active, inactive, or pending. Now, when do we use types versus interfaces? Interface we should use whenever we are modeling object structure, specifically when we want to extend them. They are much more cleaner to read that way. We already saw them. Employee extends person. It's very explicit and clear to understand that, okay, employee is now extending person. That means it's adding some property on top of person. Now, whenever you're working with libraries like React, where many APIs use interface for props and component types, it makes sense to go with interface. And whenever we want to take advantage of declaration merging. When we should be using types, you can work with primitive types, unions, intersections, or definitely when dealing with tuples. And whenever we want to define function signatures, as you saw for greeting function, we defined a signature, the call pattern that this function has to be called this way and return appropriate response. And we can combine types in a more flexible way. You can also use a combination of types and interface to achieve something that you want, and that's also perfectly valid. It will depend on use case to use case, and we'll get better understanding as we develop applications with time. And now let's go ahead and dive into our React component. All right. So to understand implementation of TypeScript a little better, I have created a card component. This is a very simple component that takes in certain props, which is title, your on-click handler, which will be called on click of a button, the color of the card, the content of the card, and the footer. So content, footer, and other things are conditional. If you pass them, you can see, for example, if content is not passed, then it will not render this entire section. So only when content is available, this section gets rendered. And same goes for footer. So when you don't pass anything for footer, the footer section will not come up at all. And there is some CSS as well. It's a generic CSS. For color variations, I'm providing 4 classes, which are primary, secondary, danger, and success, having all of the 4 mentioned colors. And then there are some generic styling, how the H2 and paragraph needs to look like. Then you have your button styling and certain experiences on hover. The server is already running using npm start, and this card component that we see is imported in the app.tsx file. So let's have a look how it looks. This is the component. This is the card component. When you click on it, comes up. Now, how would TypeScript make this better? First of all, we know that from CSS, I've added 4 different color possibilities, which are primary, secondary, danger, and success. But through our component, we don't get that information anywhere, including in app.tsx. If I add color, so it tells me, okay, color is there. It can be undefined or string. But what values do I need to provide? Nothing. One of the things where we would possibly have to refer to the component documentation, or for example, some other team member of yours has worked on this component and added the color definition. You would have to go back to the component again and again to understand what all parameters we can pass, what are the restrictions in place. And that's where TypeScript comes in really handy. Let's start implementing TypeScript on this component. First of all, I will rename this card.jsx to card.tsx. Rename. It's a tsx file now. Yeah. So here, now we see this error. Binding element title implicitly has any type. This is coming up because we are typing in strict mode set to true in our TS config. In case you're not aware of it, please visit the previous video. I'll link it in the info section and also towards the end of the video. It will walk you through all the key properties of tsconfig and will help you set up a generic TypeScript app using Create React App. And in case you're aware, let's continue. So title, now it's showing that it's an any type. It's not able to infer what is the type that needs to be assigned to the key title. And same goes for on click. So let's add those type definitions. How do we add the type definitions? We create an interface. Interface. This is an interface that we are defining to give type definition to props. So we call it as card, your component name, props. Interface card props, and then you start the definition. Title would be of type string. On click, an optional attribute which would be of type, it will be a function that does not return anything. Color, optional property, let's have it as a union type of primary, secondary, danger, and success. Now color is defined. The next one that we have is content. Let's make content to be of type string and make it optional. And the next one, footer, is also of type string. We save it. Now, even though we have declared this interface, we are not consuming or tying our component anywhere. How you can tie this in is, we need to declare that this card component is of type react.fc, which is functional component. And functional component can be parameterized. So we can pass card props to it. And here we see, now it automatically infers that all the props coming in have to be tied to this interface where it will automatically take the definition from there. So title now is of type string, on click is of type function, which returns nothing or would be undefined because it's optional. And now how this helps in tooling. Let's have a look at app.tsx. I want to add color, but what are the values of color? And it tells you, you can have these 4 variations. And let's implement success, save it, and have a look. See, the experience of the card changes. Now we have a very clear call out. Okay, the card can support these 4 variations in terms of colors. We can use any of them and see how the component looks. We don't have to go back and forth between the components and the documentation to understand what are the allowed values. Same. Now content, optional. I'll save it, and here we can see the content comes up. Now let's add another property. We'll go ahead and add border style. Border style will be an optional property which could be set to solid. These are all CSS border styles that we are talking about. So it could be solid, dashed, or none. So a new property came up. It's an optional property, that's why no error. But now when we go to our component and press Control space, that what are the props that I haven't destructured right now? It will tell you border style is available. And we can assign some default values to border style. So let's default make it none. And let's use this property here. In this, style is equals to border style. Save it. And now border style none will be applied at the card level. Let's go ahead and check. I'll inspect the card. And here we see border style is set to none. Now let's go ahead and change the default to solid. And we can see the solid border comes around our component. So now when implementing this property, you will have the option to provide border style as well. So border style now comes up, and border style I can provide dashed, none, or solid. So if we put in dashed, you see dash border comes up on your component. And that's how TypeScript will really help when you're putting in props or introducing new props to your component. And you see how easy it is to tie your component interface, the prop interface that you have created, to your card by just adding in this definition. And in case you don't want to have this react.fc, you can have fc imported from React. So functional component from React. So card is of type functional component, which will take props of this particular type. And then you can destructure them and use them in your application. So what did we achieve using this? So TypeScript gives us stricter control over what goes in and out of our components. We were able to see that now border style will allow only these 3 values. If you put in any other value which is not supported, dotted border, I do not have it. The component will error out, and if you see, you will see compilation error appropriately come up in your console as well. So whenever I save it, The border style is not supported. We can see the appropriate compilation time errors comes up. So type dotted is not assignable to type solid dashed or none. Here you see. So you can either leave it blank and still the error would go away because we have a default set. And in case you want to assign a value, it needs to be one of the approved values and still it will work. So this way, it allows you to have stricter control over what goes in and out of your components. You get fewer runtime errors as we just saw because TypeScript automatically calls out the compilation time errors during the development. And it's a clearer application interface for our components. It very clearly calls out that these are the properties available, these are the properties which are optional, which are not optional, and what are the values that you can provide to them. Hope this example was clear and was not too complex. It's a very easy implementation. And that's how usually we implement TypeScript in our components. You see, we are using types, it's of union type that we are using in combination with the interface and then coupling that interface to our React component. And that allows us to use it appropriately. If you're new to TypeScript, I highly recommend starting to implement it in your React projects. Even on a small scale for one or two components. Your remaining components could be of JSX type. For some of the components, if you have a TS config and the appropriate configurations available, you can go ahead and rename them to TSX and start migrating them one by one. You'll quickly see how it helps you catch mistakes early on and ensures that code is much more predictable. So in our next session, we will try and develop an application which is TypeScript end to end. All the components will be using TypeScript. We'll define the model schema. We'll use the interfaces not only to props, but also to model our API responses, and we'll take it from there. Hopefully, this session was clear and a good introduction to how you can introduce TypeScript to your existing components and how it makes the overall workflow a lot cleaner and easier to understand for everyone. Thank you for joining in. See you in the next one.